3 बजे
Hello everyone, good afternoon. Welcome to iQuanta and in NMAT SNAP practice series. This is another session of Quant and we are going to continue our session on permutation and combination from yesterday. Yesterday we were able to solve lots of questions and we were also able to understand different type of cases those can be asked on a particular concepts, right? Apart from the questions that we discussed, we also discussed some uh, difficult level of questions, right? And some concepts which are not very popular. So I hope all of you are feeling confident about your preparation now and you got something to learn yesterday. And today also I have taken some amazing questions. You will enjoy solving those questions. And we already have few students. We have Bhavana here, Priyam here, Priyanshu here. Good afternoon everyone. So let's quickly move on to our first question today, which is this one. How many 4-digit numbers divisible by 5 can be formed with the digits 1, 2, 3, 4, 5, 6 and 6? So 6 is repeated twice. Number should be divisible by 4. Number should be divisible by 5, right? Good afternoon, Paris. Good afternoon, Anamika. 420 is not in the option. Priyam is saying option A. Okay, we will check it. Now I'm not sure that this is 6 and 6 or 6 or 7. So we will discuss both the types. Okay, and let's see which matches our options. If it's 6 two times, or instead of 6 if it is 7 or 8 or any other digit which has not been used here. Anshika is saying 288. All right. Okay, you guys try solving this question taking this digit as 7, okay? Taking this digit as 7, because I got a good feeling that options will match only if we take 7. Otherwise, we will check. That must be a typo there. Farab is saying C. See, how many 4-digit numbers which are divisible by 5 can be formed with the digits 0, 1, 2, 3, 4, 5, 6 and 7. Starting with that. So, a number is divisible by 5 and unit digit is 0 or 5, right? So, we will have to consider two different cases. Case 1, when unit digit is 0, okay? When unit digit is 0. So what will happen? We have 4-digit number. So if I put 0 here, then what options do we have? We can fill this place by remaining any of the 7 digits, 1, 2, 3, 4, 5. So 7. This will be any of the 6 digits. This will be any of the 5 digits. So 7 into 6 into 5, which gives us 210. And then we will take case 2, where when unit digit is 5. When unit digit is 5, what will happen? 4-digit number 1, 2, 3, 4. Now you cannot put, you can put 5 here, you should not put 0 here, because then it will not be a 4-digit number. So how many digits can we fill here? So out of 7 plus 1, 8 digit, 5 is here, 0 cannot be here. We can place 6 digits here. And then this place can be filled with 6 digits again. And then this place can be filled with 5 digits, right? So 6 into 6 into 5, that will be equal to 180. So our answer will be, if we add these two, 210 plus 180, this will be equal to 390, right? So that's the answer. If we take this instead of 6, this is 7. But I guess if we take 2 sixes, then what will happen? This is the answer. Is that clear to everyone? Whenever you have 0 in as one of the digits, you should be always careful, because you cannot place 0 in the first place. So you cannot be solving this question as unit digit will be 0 or 5, right? Unit digit will be 0 or 5 and then take the rest of the digits in single case. That would be wrong. Paris, yes, if they are not, it's not mentioned that, but using form with the digits 0, 1, 2, 3, 4, 5, 6 and 6. So for this it will be 390. But let's say if it is 0, 1, 2, 3, 4, 5, 6 and 6. So only 6 is being repeated. Only 6 is being repeated. So how do we solve this? So again, we will have to consider two cases. First, case 1, when a unit digit is 0. When we have unit digit as 0. So how do we solve this question? First, again, we will have to consider case 1a. As a little, unit digit is 0 and, okay, unit digit is 0 and only 1 6 is used. Only 1 6 is used. So what will happen in that case? 1, 2, 3, 4. So let's put 0 here, right? And only 1 6 is used. That means we can fill 6 digits here. Then we can fill 5 digits here. We can fill 4 digits here. So 6 into 5 into 4. This will be equal to 30, 120, right? And case 2. Case 2, when unit digit is equal to 0 and 2 6s are used. 2 6s are used, right? 2 6s are used. So what will happen? 1, 2, 3, 4. So 0 will be here. Now out of these 3 places, 2 places we need to fill 6, right? And rest we can use 1, 2, 3, 4 or 5. So number of ways, what will be the number of ways, number of such numbers? So first of all, in which of these place we are going to use 1, 2, 3 or 5? So there are 3 options, right? It could be 6, 6 or something, 6, 6 or something, or rightmost. So 3 into, now 5, any of the 5 digits can be used, right? And what will happen? Is that it? 3 into 5, 6, 6, 1, 6, 6, 2. Yes, it will be 3 into 5 into 1, and this will be equal to 15 days. Tell me, is this clear to everyone? Second case, 6, 6, 1 or 2 or 3 or 5, 4 or 5, right? Then 6, 6, okay? This will be 15. Similarly, case 3, unit digit is equal to 5 and 1, 6. Only 1, 6 is used. Only 1, 6 is used. What will happen in that case? Again, how many numbers will be there? So 1, 2, 3, 4. So 5 will be here. Now out of the remaining 6 digits, what will happen? You cannot put 0 here. So number of ways you can fill this place is 5, then 5, then 4. 5 into 5 into 4, which is equal to 100. And then we talk about case 4. Unit digit is equal to 5 and 2 6s are used. And then 2 6s are used. So what will happen? 1, 2, 3. Again 4. Put 5 here. How many cases will be possible? How many cases? If I take 6, 6 here, you cannot put 0 here. You can put 1, 2, 3, 4. So 4 cases here. But if you take 6, 6 here, you can put 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. 5 digits. Then if you take 6 here, you can put 0, 1, 2, 3, 4 here. So there will be a total of 14 cases. This will be 14 such cases, right? So the total number of such numbers will be 120 plus 15 plus 100 plus 14. So 249. That's the case. This is the answer, right? So our answer is option B, 249. All right. So this was an interesting question. As you can see, we have to consider different cases. बताओ है कोई doubt? Priyam, see, 1, 2, 3, 4. This place is 5 fixed, right? 1, 2, 3, 4. 1, 2, 3, 4. If I put 6, 6 here, or 6, 6 here, or 6, 6 here, this value can be 1, 2, 3 or 4. Now this value can be 0, 1, 2, 3, 4. This value can be 0, 1, 2, 3, 4, right? And 5 is at unit place. So here you are not taking 0, right? So 4 cases, 5 cases, 5 cases, total 14. Okay, is that clear now? Priyam? ठीक है. किसी को डाउट है किसी भी केस में, then let me know. Case 1, 2, 3, 4. Okay. Otherwise, I am moving to the next question, which is this one. How many 6-digit number can be formed from the digits 1, 2, 3, 4, 5, 6, which are divisible by 4 and digits are not repeated? Digits are not repeated, but we need to find how many numbers will be divisible by 4, and that is also 6-digit numbers, and we have 6 digits here. What's the answer, guys? Why so slow? Let me give you an hint. Divisibility rule by 4. What is divisibility rule by 4? Last two digits should be divisible by 4. Right? This is important to solve this question. So 1, 2, 3, 4, 5, 6. Right? What should be the last two digits? Should that it's divisible by 4. Starting by minimum. Last two digits could be 12, 1 and 2, or it could be 16. Then 24. Then 32, 36. Then 44. Then 52, 54. Then 64. These are the last two digits of the number. If number is divisible by 4, using this, but repetition is not allowed, so we don't count 44. So 1, 2, 3, 4, 5, 6, 7, 8 such cases are possible. So if you are putting last two digits as x and y out of these, okay, x and y, then this can be filled with 4 ways, then 3 ways, then 2 ways, and then 1 way. So this will be equal to, total will be equal to, what will be the total? This into, how many such possibilities are there? 8. So 24 into 2, which is into 8, which is equal to 192 such numbers are possible. है ना? So lots of you got this correct. As I can see, Siddhant, Paris, and Sefali, Avi, Anamika, Avi Krishna, Priyanshu, Priyam. All of you got this correct. That is good. Thumbs up. Let's go to the next question then. And case work भी कर सकते हैं. What type of case work apart from taking last two digit? Priyanshu, What do you mean by casework? Like these are the cases we need to consider, right? Each case number of numbers will be same. So why do we need to take different cases? Hannah? You can take the casework as, I guess, if the unit digit is 2 or 4 or 6, right? Then lots of cases. We will have to consider 3 different cases. Okay, then comes the next question. In how many ways can Ram choose a vowel and a constant, not constant, should be consonant, should be consonant from the letters of the word Allahabad? Five. Five or 4? See, vowels we have A only if we talk about distinct vowels. Consonants we have L, H, B and D. So number of ways, what will be the total number of ways? Number of ways of choosing one vowel is exactly 1, which is A. Number of ways of choosing one consonant is 4. Out of 4, we need to choose 1. So our answer is 4, not 5, which is option A. Hannah? Shefali, is that clear? I guess there must be some counting mistake, but if you are getting 4 or 5, Nikita, it's 4, you know. Avi Krishna, Paris, Avi Krishna got this correct. Paris, check your answer. Anamika got this correct. Priyam and Shefali got this correct, right? We will choose L only once because we need to take only one consonant. So out of 2 L's, in how many ways you can choose one L? Only one. But both the L's are similar, right? All right. Then comes another question which is based on the concept that we learned in the last class. Alphabetical order, right? Number of ways in which the letters of the word garden can be arranged with vowels in alphabetical order. what will be the number of ways? Alphabetical order. So 360 is the answer. Yes, it will come. A will always come before E, right? A will always come before E. That's it. So if we have 4 consonants and we have 2 vowels, so total of 6 factorial. Hello Akul, good afternoon. So what will be the total number of ways or total number of words? So 6 factorial, and these vowels can be arranged in themselves in 2 factorial ways, right? So divide that by 2 factorial, which will be equal to 360. So our answer is option A. Okay, let's see how many of you can answer, how many of you focused in last class. In how many ways, how many words are possible such that these vowels are not together? Although this can be solved in complementary method as well, the negative statement, but still vowels are not together. Not together 240. टुमारो कॉन्सेप्ट प्रेम कल तो अभी तक आया ही नहीं है. 480, it's 480 that vowels are not together. कैसे बताया था? Write down all the consonants first. G, R, D and N. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. So now I can put these vowels in any of these 2 places, any of these 2 places. So what will be the total cases? So first vowel can be put in 5 ways. Second vowel can be put in 4 ways. And then these 4 consonants can be arranged in themselves in 4 factorial ways, which is equal to 480. ठीक है? Which is equal to 480. ठीक है प्रियम, this is the concept that we learned yesterday. Whenever we are talking about things not being together, okay, so arrange the rest of the things and make a space between them and then solve it like this. If you put these vowels in any of these 5 places, the 2 vowels in any of these 5 places, then both of them will not be together. Okay. Okay, can you tell me, can you answer this, that vowels are in alphabetical order as well as not together? Vowels are in alphabetical order but not together. Then how many such words are possible? बताओ. Vowels are in alphabetical order but not together. $240, right? Yes, 240. Simply you can divide this by 2 factorial. 480 by 2 factorial. Because in this case, A first, E first, both the cases are counted. So 480 upon 2 factorial, which is equal to 240. So yes, that is correct. The answer for this question is 240. And you can see all three are in the options. Okay, next question. There is a question paper consisting of 15 questions. And each question has an internal choice of 2 options. In how many ways can a student attempt one or more questions of the given 15 questions in the paper? What's the answer? Option D. Yes, option D is absolutely correct. So we have 15 questions consisting of 2 options, right? We have 15 questions consisting of 2 options. Now, if a student is attempting a question, he has 2 options, right? He can choose any of the options, but we need to say in how many ways he can attempt one or more questions. So there is also the possibility that he is attempting the question or not attempting the question, right? So there are 3 options for the student. He is choosing one of the 2 options, or he is not attempting the question. So for each question there are 3 operations that can be done. So it should be 3 to the power 15, but there is one catch. What is that catch? That it should be at least 1 or more questions. So in this case, if all the questions he has not attempted, then there will be one such case that we will have to subtract. We are getting 3 to the power 15 minus 1, which is option D. Okay? So this is a really good question. Although options could have been better in the question, like 2 to the power 15 minus 1 could have been one of the options, then it would be much better question. So Akul got it correct, Paris, Siddhant, Priyanshu, Krishna, Nawab, all of these students got this correct. Very good, guys. Okay, now this is a really good question. See, in this question, Tanima, we have 3 options, 2 options given, and the student also has an option to not attempt a question, right? To not attempt a question, because we also have to take this into consideration that he is attempting 1 question or 2 question or 3 question or more than 1 question, more than 1 question. So what will happen? For every question there is 3 operation that can be done. You choose any one of the 2 options, and you also choose not to mark any of the options. So 3 things, right? right? So option A, option B, or none of the options. You are not choosing to solve it. So there are three choices per question. So 3 to the power 15. But in this case, 0 questions have been attempted as well, right? 0 questions have been answered as well. Because if I choose all of them, if the student chooses all the questions not to attempt, so he has attempted 0 question at the end, and that will be one of the cases of 3 to the power 15. But it says one or more question. So remove that case where he has not attempted a single question. That will be one case. So 3 to the power 15 minus 1. Hello? In how many ways 5 chocolates can be chosen from an unlimited number of Cadbury, 5-star and pouch chocolates? Partition formula, yes. In how many ways 5 chocolates can be chosen from an unlimited number of Cadbury? So number of Cadbury chocolates plus number of 5-star chocolate plus number of Perk chocolates. This should be equal to 5. Now it does not say that all the chocolates should be a natural number of chocolates should be natural number. So we will use whole number solution that we also discussed yesterday, that x1 plus x2 plus xr is equal to n. Then number of non-negative solutions is equal to non-negative integer solutions. Non-negative integer solutions will be equal to n plus r minus 1 c r minus 1. So here it will be total, how many such cases are possible? 5 plus 3 minus 1 c 3 minus 1, which will be equal to 7c2, and 7c2 is nothing but 7 into 6 by 2, and that is equal to 21. If you have problem understanding this formula, NCR is equal to n factorial upon n minus r factorial into r factorial. And the shortcut for NC2 is equal to n into n minus 1 upon 2. Alright. So answer is option C. So this was a quick solve. Once you understand the concept that this unlimited has not much use, right? Then comes this question: a man has 3 shirts, 4 trousers and 6 ties. What are the number of ways in which he can dress himself with a combination of all the 3? Yes, answer is 72. A man has 3 shirts, so he can choose any of the 3 shirts. Okay, so it will be 3C1 into 4C1 into 6C1, which will be equal to 72. Okay, total of 72. Paris, which class do we have? Class Savannah class or any other class? Okay, let's try this question. This is a really good question. Okay, Paris, got it. Where is that session scheduled? Not on YouTube. It's not on YouTube. Anywhere else? ये क्लास कहाँ पे schedule है? What's the answer? NPR is equal to NPR plus 1. What does that mean? NPR is equal to NPR plus 1. Can we say this will be equal to n factorial divided by n minus r factorial, and this will be equal to n factorial divided by n minus r plus 1 factorial, right? These two are equal. What we can say, n factorial is cancelled out. N minus r factorial is nothing but n minus r factorial is nothing but n minus r into n minus r plus 1 into n minus r plus 2 and so on till 3 into 2 into 1. The value will keep decreasing. So if you find this value, this will become n minus r is equal to 1, right? And the second one, what do we know? That NCR is equal to NCR minus 1. So remember, whenever you have NCX is equal to NCY, then we can say that x is equal to y or x plus y is equal to n. So r and r minus 1 cannot be equal. So what we can say that r plus r minus 1 is equal to n, or 2r minus n is equal to 1. So add these two equations, 1 plus 2, what do we get? R is equal to 2 and so n is equal to 3. So answer is option B. अच्छा, paid class on FB. Okay, no worries. जो भी एक दो क्वेश्चन रहेंगे you can watch it later, okay? But जो भी लोग देख रहे हैं उन्हें समझ में भी तो आना चाहिए, right? You can also take the value of n from here, that n is equal to 2r minus 1, or you can put it here. Like if you put, instead of doing this, if I put n is equal to 2r minus 1, what will happen? 1 upon 2r minus 1 minus r is r minus 1 factorial is equal to 1 upon 2r minus 1 minus r minus 1 is r factorial, or yes, r minus 1 will be equal to 1, right? R minus 1, this is 2r minus 1, so यहाँ पे कुछ और आएगा 2r minus 1, I will have to check it, but anyway यहाँ से भी आंसर आ जाएगा कि r is equal to 2, कुछ यहाँ पे I guess रह रहा है, उसकी वजह से नहीं आ रहा, but even if I put this here from here n is equal to 2r minus 1, we should get the answer, है ना? Okay, let's go to the next question, which is this one. This you can solve quickly. We have also discussed about these type of numbers in yesterday's class. Yes, I got the mistake here that we were getting. If you put n is equal to 2r minus 1, then this will become 1 upon r minus 1. So r minus 1 factorial 1 upon, this will become r minus 2, right? 2r minus 1 minus r minus 1. So r minus 2 factorial. So from there we get r minus 2. Again the same mistake. I don't know what is happening, but something is not making sense here. R minus 2. Acha, r minus 1 will become 1. R minus, because this will cancel out this by r minus 1. Here r is equal to 2. So instead of solving the linear equations, we can also use this. Now this question, if 10PR is 720, then R is equal to, so what will happen? 10 factorial upon 10 minus R factorial is equal to 720, right? 10 factorial upon, so we can say 10 minus R factorial is equal to, what will be this value? So this value will be equal to 5040, or we can say, which is equal to 7 factorial. So R is equal to 3. Answer is option C. Alright, चलो कुछ अच्छा क्वेश्चन करते हैं. Let's try this one. Let's see how many of you can solve this question. वैल्यू सब्स्टिट्यूट करना बेटर होता है क्या? अकुल, आई गेस yes, it would be better to substitute the value because in this situation we easily got two linear equations. Okay, otherwise whenever there are two variables, two equations, it's easier to use the elimination method. But in this case, sometimes you might get quadratic, right? One linear, one quadratic. So it's better to substitute one variable with the other and then solve. Kumar, Shivam, Pranesh got 7. Okay, anyone else? Pranesh, wait for a minute. Let's get more responses, then I will reveal the answer. Priyam is saying 9. Shefali is saying 7. Nawab is saying 7. Akul, it's not a difficult question. See, 28C2R, can I write it as 28 factorial upon 28 minus 2R factorial into 2R factorial, and this divided by this, so this will become, this we can write as, in denominator it will be 24 factorial, then 24 minus 2R minus 4 factorial into 2R minus 4 factorial. This is equal to 225 upon 11, right? So can I say 24 minus 2R minus 4 factorial 4 is nothing but 28 minus 2R, right? So can we cancel this out? We can cancel out this by this, right? Then this 28 factorial upon 24 factorial will give us 28 into 27 into 26 into 25. 2R factorial minus 2R minus 4 factorial will be 2R into 2R minus 1, 2R minus 2 into 2R minus 3, right? This will be equal to 225 upon 11. 25 into 9 is 225. 9 into 3 is 27. Now can we write that 2R minus 3 into 2R minus 2 into 2R minus 1 into 2R is equal to this product, right? Which is equal to 28 into 3 into 26 into 11. These are nothing but 4 consecutive natural numbers, right? These are nothing but 4 consecutive natural numbers. How do you break this so that you are getting 4 consecutive natural numbers? So you can write it as 11 into 12 into 13 into 14. Okay? So we can say 2R is equal to 14 or R is equal to 7. So that's the answer. Hai? That's it. So yes, Kumar, Shivam, your answer was absolutely correct. Shefali got this correct. Nawab got this correct. Paris got this correct. And Anshika got this correct. Very good. This was not an easy question. Not an easy question in terms of solving all this, right? And in the end, factorizing this as a product of 4 consecutive product. How we take, see, 28 can be written as 14 into 2. 16 can be written as 13 into 2. Now this 2 to 3, give this 2 to 3, it will become 12. So 14 into 13 into 12 into 11, right? How did we assume it? We did not assume it. These are 4 consecutive. These are 4 consecutive integers, right? So right hand side, if you are going to solve it, it will become degree 4 equation, right? So instead of that, if we know that left hand side all the values are natural numbers, so try to make those consecutive natural numbers on the right hand side as well, right? Shefali, short trick. No, I don't think so. At this time, I don't have any short trick for this question. We will have to do all this. I know. Okay. चलो next question try करते हैं. In a company, each employee gives a gift to every other employee. If the number of gifts is 56, then number of employees in the company is. Shefali, are you talking about the factorization or the whole solution? Because I thought you are asking about the whole solution. If it's about the factorization, then yes, you can move by prime numbers, because prime number cannot be factorized, right? And check what prime numbers are there. Like one of the prime factor is 11, one of the prime factor is 13, one of the prime factor is 7, right? So 11 and 13 are there. So those numbers, out of those consecutive numbers, one of them must be 11, other must be 13, or maybe multiples of that. But 22, 26, you are not going to get that big numbers, right? Whole solution. No, for whole solution, I don't think so. But for factorization, you can go by prime factors. This is a very straightforward question. In a company, each employee gives a gift to every other employee. So what we can say, n into n minus 1 is equal to 56. Now remember, I always try to do this whenever I know that left hand side, the variables that has been used are natural numbers or even integers. Okay. So what I try to do, I try to factorize right hand side. Instead of solving the quadratic, I always try to factorize the number in that form. So 56 can be written as 8 into 7. So n is equal to 8. We don't need to solve the quadratic. You can always try this and you will save a lot of time, because most of the time when integers are mentioned in the question, it becomes very easy to solve these type of questions. Okay. Consecutive numbers. Yes. Let's try the next question. The digits from 0 to 9 are written on 10 slips of paper, one digit on each slip, and placed in a box. If 3 of the slips are drawn and arranged, then the number of possible different arrangement is. So once again, this is a direct formula based question. We need to arrange 3 things taken out of 10 things. So 10p3, which will be equal to 10 factorial upon 3 factorial. This is the case, right? Is that the case? 10 factorial upon 7 factorial, that will be, which will be equal to 10 into 9 into 8, which is equal to 720. Option B is the answer. All right. Chalo. One last question for this session today, okay? And then we are going to have our quant problems next week, quant practice, Monday and Tuesday, 3 p.m. onwards, with some new topics. And I will try to consider request done by someone from yesterday's class that one more session on numbers. So I will try to take one more session on numbers, okay? If P 32 6, P means permutation. Permutation of 6 out of 32 objects is equal to combination of 6 out of 32 objects into K. And what is the value of K? So question is 32p6 is equal to k into 32c6, or this will be 32 factorial upon 26 factorial is equal to k into 32 factorial upon 26 factorial into 6 factorial. So all of these are cancelled out. We are getting k is equal to 6 factorial, which is equal to 720. Okay. Again 720. Yes. All right. So, all right, everyone. With that, we are done with the session today. We will meet again on the Monday. Till then, try our logic builder puzzles for CAT. Okay, you can find those videos in the video section. I am giving puzzles in CAT preparation iQuanta Facebook group, and those puzzles are really good for understanding how to approach a particular type of set, or how to use the given information as per the requirement of the given set. So those are not LRDI set. Those are very small puzzles, but tricky puzzles, okay? It goes by logic builder puzzles for CAT, okay? My name would be somewhere there. So you can find it in the video tab. So go there, and I have posted 2 logic builder puzzles for CAT till now. So try to watch those videos. It's fun, okay? And let me know your feedback in the comment. All right? So thank you for joining us today. Bye bye.